As we work on this file, please keep in mind that as you go through the steps, you keep the boxes checked. So we're given an equation, x squared minus 3x minus 28 equals to 0. Now we're looking for the zeros. In order for you to be able to find the zeros, using what we want to use today, which is the quadratic formula, we need to make sure that your equation is already in ax squared form, the bx, and the c. And in this case, we could see ax squared plus bx plus c is equal to 0. So looking at that, we should be able to know, hey, I should be able to use the quadratic formula, which is this that just popped up. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. We must identify the values of a, b, c. Now, once again, a is a number in front of x squared by looking at this formula right here. B is the number in front of x, and c is the number without a variable. So, looking at the equation that was given to us, there's no number in front of x squared, but it's understood to be a 1. The number in front of your bx is a negative 3, and then the number by itself without any x's is your negative 8. Therefore, your a is 1, b is negative 3, and c is negative 28. Now we must substitute the values in the appropriate place. So using the formula that's in red, we need to substitute a negative 3 for both b's, a 1 for the a's, and the c gets replaced by a negative 28. So we look at this formula, and we need to keep in mind something when it becomes multiplication, but when you have two negatives, you should know that it becomes a positive. And when you multiply a negative 3 times a negative 3, that right there becomes a positive 9. Also keep in mind that we're going to go ahead and work on everything that's inside the square root, and then go ahead and move on from there. So the next step, we're simplifying a little bit. That those two negatives became a positive 3. The negative 3 squared became a 9. The negative 4 times 1 times negative 28 became a positive 112. Now, when we look at this, we should be able to see that we're able to perform the operation inside of the square root, which in this case is addition. 112 plus 9 would give me 121. So the question now is, can I take the square root of 121? The answer should be yes. So the square root of 121 is 11. So we go ahead and show that step. So x equals 3 plus or minus 11 over 2. In this part, we're having to split the problem into two problems. So why is it split into two? Because of the plus and minus situation. So we end up with x equals 3 plus 11 divided by 2 and 3 minus 11 divided by 2. So we're going to get two separate answers. That means we have two zeros, two solutions, two x-intercepts. So we simplify, and we have 3 plus 11 divided by 2 and 3 minus 11 divided by 2. And these are the two answers that we end up with. Now we're supposed to go ahead and evaluate all the way through. 14 divided by 2 is 7, and negative 8 divided by 2 is a negative 4. So using the quadratic formula, we have found out or figured out or calculated that our two zeros are when x is 7 and also when x is a negative 4. But let's go ahead and graph this by putting in y equals x squared minus 3x minus 28. And when we graph it, the graph will appear right there on the right side, And we're going to see if the two zeros that I have right above, which are 7 and -4, actually cross the x-axis, if the graph actually crosses the x-axis at those points. So we hit graph, and if we see over here, here's my graph. It is crossing at a -4, and that's exactly what we have over here, and it's crossing at a +7, which is also the other answer. So the graph is another way to prove that yes, the quadratic formula does work. It gives us the answer when we're looking for them. So go ahead and use the quadratic formula for the rest of the problems.